Hi everyone, welcome to my channel Design with Uzbek. Continuing with CSWA practice problems, today we'll work on question 5.1. This is the first question from chapter 5 of the problem set. These questions in general are more complex, so what I'm trying to do, I'm trying to explain every details step by step so the solution is clear for you. So without further ado, let's start working on this question. In this question, as you can see, unit of measurement is millimeter gram second. Like always, we need to ensure we are using the same unit of measurement in SolidWorks setting. Now, looking at this geometry, you can see the top view, you can see the 3D model, this is a front view, and this is section AA. My preference is to focus on the top view. First, I'm gonna make a 2D sketch of the top view, just this portion. And then I'm gonna make a plane parallel to this line, basically parallel to section AA, and I make a 2D sketch of this part of the geometry, and I'm going to extrude that. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first thing first, we need to check unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement. Now I want to focus on the top view, so let's click on the sketch, and choose top plane. So here, I'm gonna start with making a rectangle. Click on rectangle command, and then here I'm gonna make a rectangle. Now, looking at the top view, you can see that the width of this rectangle is 108 millimeter, and the height is 64 millimeters. So this should be 64. Also, you can see that we have a chamfer in this corner. It's 18 by 18. So what I can do from a sketch, I can click on the drop-down menu for the fillet and I choose sketch chamfer. And this one, I'm gonna change it to 18 and I select this corner. Next, we need a line from here to here. So what I can do, I can click on line command and I'm gonna make a line from here to here. For the line, if you look at the top view, you can see that the angle is 35 degrees. So this angle should be 35. Also, the distance between this point and the left side of the geometry is 54 millimeters. So this is 54. And that's enough to define this line. Awesome. So now all I need to do, I can click on trim entities and I can get rid of this line and this line. Okay. Of course, after removing those lines, now the geometry is not fully defined. Let's see why this is not fully defined. I can click on one point and I can move it, and I can see that I can move it up and down. This means that the height of the geometry is not defined. We actually define the height, but because I trim part of the geometry, that dimension is gone. All we need to do is to add that dimension. Click on the smart dimension, and the height of the geometry should be 64. So this is 64, and same thing for the width. The width of the geometry is 108, so this should be 108. And now you can see that the geometry is fully defined again. Awesome. So now in the corners, we need fillet. The radius of the fillet is 12 millimeters. So I can click on fillet command. I change the radius to 12 and I choose this corner and this corner. Click on OK. We also need two holes in the center point of the fillet. So click on circle command. The diameter of the hole should be 10 millimeters. So I make one hole here and one here. And the dimension should be 10 millimeter. This one is also 10 millimeter. Awesome. So now we have the ballpark of the geometry from top view. Let's click on feature, click on extrude bus, and then here, if you look at section AA, you can see that the thickness of the part is 4 millimeters. So I change the thickness to 4, and that's it. Awesome. So this is the first part of the geometry. Now we need to focus on the second part, which is the bend part here. In order to make that a sketch, all I need is a plane. So let's click on feature. And then from the options here, click on reference geometry. And here you can see that we have different options. I click on plane command. This command helps me with adding a plane, okay? So all I need here is a plane perpendicular to this line. And it also needs to pass through this point, this line basically. So for the first reference, I'm going to select this line. And now you can see this is the plane I have. This is not good for me. I want this to be perpendicular to this line. So for the second reference, I select this line. And now you can see SolidWorks automatically change the plane. It's not perpendicular. It's actually parallel to that line. So all I need to do for the second reference, I can change the relationship to perpendicular. Change it, and now you can see that this is a plane I want to have. So now click on OK, and that's it. That's a plane. Okay. Now all I need to do is to draw a 2D sketch on this plane and then extrude it. So let's click on the sketch, and this plane is now selected. Okay. So what do we have here? We have one line, something like this. And we also need an arc shape, something like this. First, the length of the line is 14 millimeters. So click on the smart dimension and this should be 14. We know that this line and the arc, they should be coincident. So I select coincident. Also, the arc that I have, it should be tangent on both ends. So I select the arc, I hold Control, I select this bottom line, and from the relations I choose tangent. I repeat this again. I select the line, I select this line, and from the options I choose tangent. Also, the radius of this arc is 12 millimeters according to section AA. So I click on the smart dimension and this radius is 12. Okay, now you can see the arc is fully defined. Next, we know that we have a consistent wall thickness which is 4 millimeters. So here I can simply click on offset command. I change it to 4 millimeter because I need a 4 millimeter offset, and I simply select this arc. I don't need a chain, so let's uncheck select chain and let's check reverse because I want it to be on the other side. So that's the offset arc. Click on OK, and finally I'm gonna have one line here and something like this. Of course, the end point, this line and these line, they should be perpendicular. So from the options on the left side, I choose perpendicular, right? Also, according to question, the angle between this line and this top surface should be 112 degrees. So I select it and I change it to 112. And now you can see that I have a fully defined geometry. Now, all I need to do is to close this contour. Click on line command, and from this point to this point, I just make a line, and now I have this. Now, all I need to do is to extrude this geometry. To do this, click on feature, click on extrude bus. This geometry is selected, this contour. Let's change the direction, and from the drop-down menu, I'm going to choose up to vertex. This means that I have to define the endpoint. And for this extrusion, I'm going to choose this line. And now you can see the extrusion is happening. It starts from this point and it's going to end here. Click on OK, and that's it. Awesome. So that's the final geometry. That's all we need for this question. Now, just to make sure that this is the correct model, let's go back to the question and check the final answer in the question. In the question, you can see the total volume. The total volume is 28,862 cubic millimeters. Let's go back to our model and check the total volume for our model. In SolidWorks, in order to check the total volume, you can click on Evaluate and then Mass Properties. And here you can see the final answer. The total volume that we found is 28,861 cubic millimeters. If you round up this number, you're going to get exactly the same answer as shown in the question. This is telling me that my model is correct and there's no problem with it. Okay, awesome. I think that's a wrap for this video. It was a quick video. I hope you guys enjoyed this video. If you have any comments or feedback, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.